Welcome back. We are on the topic ratios and rates. In the previous videos, we have learnt more about ratios. In this video and the subsequent ones, we will concentrate on the second part of our topic, which is rates. So let's learn more about rates. Rates are similar to ratios. In the videos on ratios, we learnt that ratios compare one quantity to another, and the quantities must have the same unit of measurements. We have seen that rates are similar to ratios in that rates also compare one quantity to another. So ratios compare one quantity to another, and rates also compare one quantity to another. But in rates, the quantities that are being compared have different units of measurement. So in ratios, the quantities that are being compared have the same unit of measurement, but in rates, the quantities that are being compared have different units of measurement. Let's learn more about rates. Consider this example. In an examination, a student answered 120 questions in 60 minutes. So likely this was an objective test, and in 60 minutes, the student answered 120 questions. We can compare the number of questions the student answered to the time it took the student to answer those questions. In ratios, we learned that the ratio of the questions to time is 120 questions is to 60 minutes. The ratio of the number of questions the student answered to the time it took the student to answer that is 120 questions is to 60 minutes. We learned from ratios that 120 questions is to 60 minutes can be written as 120 questions divided by 60 minutes. We learned this in ratios. Now, 60 will cancel itself 1 and cancel 120 2 times. So you will have 2 questions divided by 1 minute. Let's separate the numbers from the units. You have 2 divided by 1, then we have questions divided by minutes. 2 divided by 1 will give us 2. Questions divided by minutes will be written as questions per minute. So when we break this down, we will have 2 questions per minute. This means that the student answered 2 questions in every minute. This is an example of a rate. It shows us the number of questions the student answered in a minute. From the example, we are told that he answered 120 questions in 60 minutes. By using ratios, we have been able to break it down to know that the student answered 2 questions per minute. This means that in every minute, the student answered 2 questions. Now let's consider something here. In ratios, we learned that the quantities that are being compared have the same unit of measurement. So when you divide one quantity by the other, the units will cancel out. So the ratio will have no unit. So a ratio does not have a unit. But in rates, the quantities that are being compared have different units of measurement. So after dividing one quantity by the other, the rate will have a unit. In this example, the unit of our rate is questions per minute. We have 2 questions per minute, and as we have seen, it means that the student answered 2 questions in every minute. So when you see 2 questions per minute, what it means is that the student answered 2 questions in 1 minute. Finding this rate is very important because with this rate, we can use it to find the number of questions the student answered when the time changes. We can also use it to find the time that it will take the student to answer a certain number of questions. For example, using this rate, We can use it to find the number of questions the student answered in 3 hours. We can also use it to find the number of questions the student will answer in, let's say, 2 hours or let's say 30 minutes. So using the rate, we can use it to find one quantity when the other quantity changes. Let's consider another example. In 2009, at the IAAF Athletics Championship in Berlin, Usain Bolt completed the 100-meter race in 9.58 seconds. So Usain Bolt ran the 100-meter race in 9.58 seconds. We can compare the distance, which is 100 meters, to the time that it took him to complete that distance, which is 9.58 seconds. The ratio of distance to time is the distance, which is 100 meters, is to the time, which is 9.58 seconds. From ratios, we learned that 100 meters is to 9.58 seconds can be written in the form of a fraction as 100 meters divided by 9.58 seconds. Let's separate the numbers from the units. So you have 100 divided by 9.58 and you have meters divided by seconds. 100 divided by 9.58 will give us 10.4. Meters divided by seconds is written as meters per seconds. So this rate is 10.4 meters per second. Now what this means is that Usain Bolt covered a distance of 10.4 meters in every second. So in 1 second, he covered a distance of 10.4 meters. That is very fast for a human being. A distance of 10.4 meters in every second. As you can see here, we compared the distance that he traveled to the time it took him to travel that distance. When you compare distance to time, the rate that you get is known as speed. So here, 10.4 meters per second is the speed of Usain Bolt. When you compare distance to time, the rate is known as speed. So Usain Bolt's speed in that race was 10.4 meters per second, and that is very, very fast. Finding this rate is also very important because with this rate, we can use it to find the distance when the time changes. So let's say that he keeps on running at this same rate. We can use what we have here, which is 10.4 meters per second, to find the distance that he will travel in, let's say, 2 minutes or let's say 3 minutes. In the same way, we can also use this rate to find the time when the distance changes. So we can use the rate to find the time when the distance changes to, let's say, 400 meters. So let's say that he keeps running at this rate. What will be the time when he has covered a distance of 400 meters? So as you can see, finding the rate is very important because we can use it to find one quantity when there's a change in the other quantity. There are different examples of rates. As I've already indicated here, when we compare distance to time, that rate is known as speed. Another example of rate is density. Density compares mass to volume. So when you compare mass to volume, the rate that you get is known as density. For example, the density of gold is 19.3 gram per centimeter cube. And what this means is that the mass of 1 centimeter cube of gold is 19.3 grams. So if you take 1 centimeter cube of gold and you put it on a measuring scale, you are going to record a mass of 19.3 gram. This is a rate. Now using this rate, we can find the mass when there's a change in volume. We can also find the volume when there's a change in mass. Another example of rate is the rate of pay. The rate of pay compares money to time. Usually, it shows the amount of money an employee will earn in a certain period of time. For example, Kofi is paid 50 Ghana cedis per week. What this means is that Kofi is paid 50 Ghana cedis every week. 50 Ghana cedis per week is known as the rate of pay of Kofi. Using this rate, we can find the amount of money Kofi will earn when the number of weeks changes. So let's say that we want to find the amount of money Kofi will earn in, let's say, 6 weeks. Because we know the rate of pay, we can find that. We can also find the number of weeks it will take Kofi to earn a certain amount of money. So as we have seen from these examples and the previous ones, finding the rate is very important. In the first example, we saw that the student answered 2 questions in a minute. Using this rate, we can find the number of questions when there's a change in the time. We can also find the time when there's a change in the number of questions. In the second example, we saw that the speed of Usain Bolt was 10.4 meters per second. Using this rate, we can find the distance when there's a change in time. We can also find the time when there's a change in distance. In this example here, we have seen that density compares mass to volume. Using the density, we can find the mass when there's a change in volume. We can also find the volume when there's a change in mass. In this example here, we have seen that the rate of pay of Kofi is 50 Ghana cedis per week. Using this rate of pay, we can find the number of weeks it will take Kofi to earn a certain amount of money. We can also find the amount of money Kofi will earn in a certain number of weeks. So basically, this is the main thing that we'll be doing in rates. We will learn how to use a rate to find one quantity when there's a change in the other quantity. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to learn how to use a rate to find one quantity when there's a change in the other quantity. Bye bye.